Welcome to another workshop where we are dealing with practical questions for data management system. We have already come a bit far in our workshops where we are testing different theories with their practical approaches. So today we have picked up a question from the dummy variable regression analysis, where inside Excel we have to make or model a decision, and manually we have to measure their relationship. Inside regression analysis, you know that we have a dependent variable, and we try to find the functions of the independent variables that gives us some coefficients, and by measuring them we see the degree of dependence that we have to the dependent variable. So to simply state, let's say you have a dependent variable which is called the productivity levels, all right, and you have different categories of you have to create different categories of dummy variables to explain the relationship in your equation. And also, let's say you have given the data over 30 samples and from different backgrounds of employees. That means you have one employee from we have also those categories as well. So how we go about finding the relationship that we have between them? So if you just read the question first, here it is saying that how does participation in employee revision program affects the productivity level, right? The background is also given to us, which is, let's say they have said that use two category of dummy variables to regress. The data is collected in 30 samples from different background of employees who attended one or more revision programs. Therefore, the levels of differences in productivity may or may not depend upon the two categorical sample data that we have. So if we just go to our data, let's say this is the kind of data that we are provided with. First, just concentrate on this portion. Here you have employee ID, you have given the background of them. Let's say the first employee's background is human resource, second is also human resource. So we have total three categories here. So human resource background, from administration background, and from economics background. And they have been assessed through our productivity grading. For example, let's say the human resource productivity was 35 when this person attended our revision program. All right. So basically what it's trying to say is that you have data on three things. You have their background, you have their productivity levels, and you have the revision program. All right. So this in our case would be the reference data. All right. Okay. So now if you go further and you want to see that how this kind of relationship works and how we practically measure them using softwares to program different regression models using dummy variables. So dummy variables are really interesting because they give you a yes or no kinds of options, where say either if you bring a column for economics and let's say administration for the moment, here if you say that if the first person belongs to the 35 productivity gain, and if we have taken the revision program, then it will appear 1, right? Or it will appear 0. That means we identify them with the dummy variables so that we can communicate the measurement for the measurement for coefficients, standard errors we need, and to see their R squares using our Linus function. So we'll just go in that in a bit. What we have to do now, we have to see the effectiveness of the revision program. So we want to see if the revision program was actually effective to the productivity grade, and given also that different kinds of observation you can also bring from there is that which background, let's say we have human resource and administration and economics, so which of the three are affected to what extent with the program we have here. So in companies they might bring government revision programs, labor law programs, and a lot of stuff. So if those kinds of stuff have any influence to the employees they have, so these are important kind of explanations for the data that we have here. But the topic for dummy variable regressions is much broader, so you can implement it in different contexts. For example, you have countries, their locations. For example, in place of the backgrounds, if we had countries or some other stuff, the genders. So also categories are important, so we want to see the impact of the categories to the regression that we're gonna perform here. All right. So first, to find out the dummy variables, what we do, we use the if function. It is equal to if the first argument here, and we say that a simple logic test, if the human resource, the second cell here, is equal to the column that we have here. All right. So what we want to do is that we want to lock the first cell here. So the human resource cell is locked here, and we want to lock the column of the economics. So this way you can avoid the error. All right. So if you put a comma and we say if it's yes, then we'll say it's 1. So the machine doesn't understand yes, no, or feelings. So you have to give it numbers. So 1 means yes. That means if the human resource matches with the economics text, it will give us a 1 value. Otherwise, put a comma, it will give us a 0 value if it is false. Alright, then if you close the argument here and just hit enter, if you double click on this and drag this across, and also if you double click on this, just double click on this. Alright. If you see, the beauty of the if function is that here now how this column is identifying the data that we have in the table is that, see here, the economics portion has taken 1 value. That means this cell is going to recognize the whole economics term we have given here. So the productivity grade is 73 and the revision program was taken, let's say, 11 times. Alright, so this has taken 1, so that it has recognized economics for this column. Alright, and then same goes for the administration. See here, the administration is here and it can find all the data that we have in this particular cell here. Okay. Now we have to go for the regression, as we have our dummy variables in our disposal. Now to incorporate the dummy variables into our regression model, what we can do, we can just format our sheet like this, the right hand side of the first page that we have. Here, if you check a bit carefully, that I have taken the administration background first, then economics, then division program, the opposite of this. So why I've done that is that the Linus function provide your coefficients in the reverse order. So if there we have the division program in first, then economics and administration, here it will come as vice versa. All right. Okay. So let's say we want to put a function which is equal LINEST for linear regression. We open our argument here. Then it is asking for the dependent variable data. We have our dependent variable, which is the productivity gain. Let's control shift down to select all the data that we have. Then put a comma. And then it is asking for the independent variables or the known values that we have. All right, so we'll select, control select right, and then select the whole independent variables that we have here, the whole data for revision program, economics, and administration. Then you again put a comma. Now we also want the constant. Now here for our analysis, we have the constant as the reference group, which is the human resources. All right. So for example, if you get a number in the human resources part, it will just tell you that the HR department or the HR background will get a score if they don't take any revision program. So it's a quite intuitive understanding for a constant value. That means you will get it will be separated from the revision program part. All right, we'll put 1 for the constant, and again we'll put comma, and we'll again put 1 for the additional statistics. For example, we want R squared. Then for subsequent calculations, we will need the t statistics and the a values. For them, we also need the additional statistics as well for further inferences. Right? If you just close the argument here, and if you hit enter, see, a lot of values have appeared in our dispose. Now we have to explain them. By looking at this data, we have to explain what coefficients are giving us what type of degrees of dependencies. Alright, so let's see the constant, the reference HR group. So if they do not take any sort of revision program, so their average grade will be 32.37 and something like that out of 100. This is measured out of 100. Remember, huh? Now the revision program itself has good influence, as the coefficient of the revision program gives us a value 2.01. So every single program attended will give you a productivity gain of 2.01563332 and so on %. Alright, that means this has a significant impact. By just looking at the coefficient, you can tell. Then the economics coefficient is has outperformed. Why I'm saying it has outperformed? Because see, it has a value of almost 13. That means every single revision taken by the employees coming from the economics background, so those programs has a significant impact. So their productivity has increased over more than 12.93 and so on number. That means they will be outperforming their counterpart from the HR group and also the administration group as well. And obviously, if you are taking revision groups, you will be attending workshops and stuff like that in the company inside. So there, your productivity is likely to go up if you are taking revision programs. That is the baseline understanding that we have. Okay. Then we have a standard error given for all of this data that we have here. Now we want to go for further explaining the data. So to find the significance of the coefficients that we have given here, we need to calculate their t-statistics first. So to calculate the t-statistics, just put equal, and then we take the subsequent coefficient, we divide them by the standard error that we have. So the standard method to calculate t-statistics. Then if you just hit enter, see we have our t-statistics value. Just drag them across. We have all our t-statistics values for the data that we have here. Here also you can see that the t-values for the revision program is much higher, is a positive value and much higher. We have the constant or the reference group, which is also much higher. That means this is also likely to be statistically significant. Then for the economics group also, this outperforms. It also has a positive number, but in administration part, we do not have a significant impact over the coefficient, right? So although the coefficient does change or does shows some dependencies more than the revision program, we still don't know that if they are combined or they are alone putting this impact. All right. Now we also need the p-value. Now to find the p-value, we can use a function which is, we need a two-tailed t-statistics function. So we'll just write e dot eist dot, and you can see the 2t here, right? Just open the argument here, and we'll put the absolute value, which is the ABS of the t-stat that we have from the coefficient or the Linus template that we have. We'll put a comma, and then we'll select the degrees of freedom also. So under total t-test, we need the degrees of freedom. This is the degrees of freedom. This is 26 because we have total 30 samples, and we are to analyzing the equation, we have used 1, 2, 3, and 4 categories. See, so the 4 has been subtracted from 30. So we have lost 4 degrees of freedom. So we have 26. All right, and we have to lock this cell here. Just put a $sign before the cell that we have started. Right? If you close the argument here, and if you hit enter, right, you have to close this bracket here also. And then if you now hit the enter, see we have our p-values arrived just in seconds. So just drag them across. Now you can see that the p-values of, if we just change them into percentage, let's say we want to see them as percentage. This one, so this as percentage. This also as percentage. All right. So we have a significant result here. So the statistical inference for our first model. So this is our model 1. Model 1 is showing statistically significant result. So this is an unrestricted model for our data here that we have. All right. So we have p-value for the revision program, which is far less than 0.05%. This is also, this is even significant in 1% level. This is at a 1% level as well. So and the p-value for the coefficient of the administration is much higher. That means the administration part does not outperform their counterparts, the reference HR group. So irrespective of taking their revisions, they might not outperform in performance. Neither the economics group, neither their HR group that the reference have taken. They are not taking the HR group. Even if they are not taking any revision programs, they are likely to get this 32 point something grade out of 100. So that's how we can explain the first model that we have. So here the decision is that economics has outperformed the counterparts that they had, and the revision program obviously have a good influence on the productivity. All right. So by these statistical inferences, we can draw this decision here. Now, if you want to see that in dummy variable analysis, we do not say that one dummy variable has this type of influence, and the second one has this type of. Then go for those type of understanding. Depends on the sets of data or the kinds of observation you are doing. But it's a instrumental that you with a good reason you include an unrestricted model, and you compare that with a restricted model to see the further robustness of your data that you have. All right. To check the robustness of our Linus function here, the linear regression that we are trying to find out. Now we have to just regress the regression program with the productivity grade that we have. So we will bring a much more restrictive model now. So similar to it, I will just write the headings here first. So to check all our dummy variables are statistically significant or not, we need to go for a restrictive model. So first what we can do, again just use the Linus function equal LINEST in the argument here, then select our dependent variable here, Control Shift down, and then the comma, and again select the only one variable that we have without the dummy variable. So we'll check how we see the differences, the impact the dummy variable or incorporation of your variables to the model brings in. Right. So just select this, Control Shift down. Now if you again just put a comma and 1 for the constant value and comma again, and then 1 for again the additional statistical inferences that you want. Right. Just close the argument here, hit enter. See, we have our revision program, only one independent variable. This is you just can see that how only this one, without incorporating the administration of the economic variables here, we can just see that how the one program has affected the revision program, has certain impact to the data here. Now if you just check the R values that we have here, R values, this one, the R square values and the R square values we have here. Now what does R square value tell us? That as you include more and more variables to your data, your R square is likely to increase. That's a very good thing, right? So that means as we have included the administration and the economics category here, the categorical variable here, our R square of the model position has actually increased almost to 75%. And then it has increased from 0.59 to 0.76. That means our model shows a much more better insight, all right, for the model 1. And let's say this is our restricted model. This is restricted. Right, so we have used only one variable here. Now we also have to find the t statistics and the p-values for this model. So same how we have calculated them. So similar to the t-stat value of the unrestricted model, we can go for calculating the t-stat for the restricted model as well. So here for the first t-statistics, we'll write equal, then we'll take the coefficient of the restricted model, we divide it by the standard error of the restriction model, enter. And if you just drag them, see, we have got our t-stats. Now for the p-value as well, we will go for the two-tailed right test, t-test. So equal e dot eist dot, you open the argument here, and if you take the absolute value of these statistics, you close the bracket, and then if you put a comma, and you also put the degrees of freedom from this cell here, we log that using a $sign, right? If you now close your argument, this is how the p-value is called into this cell. So using the t-2t formula, so we take the absolute number of the t-stat that you have, the traditional method to find t statistics, and if you close the argument, if you hit enter, see, your p-value is much lesser than 0.05, right? That means this model alone, the revision program, without any incorporation of the dummy variable that we have here, it also gives us a significant statistical inference. So this is for one decision, and the first one was seeing the R square values, all right, the change in R square. So this much impact was got by the incorporation of the administration category and the economics categorical dummy variable that we have here, right? So to move further, now if you also see, we need a f test, the restricted f test and the p values. Why we need that? Because we want to see, how the how we test for the all the coefficients that we have. So incorporation of the different coefficients bring different significance. So the explanatory power is given in the unrestricted model. So in the for going to much more clearer decision, we need f restricted value. We'll write f value for that as well. Just bring them backwards, and we'll just use our traditional formula here. We have the f stat restricted here. So we say that how much the improvement is incorporated. All right. So per coefficient, we go by that. So now we have to measure how much the R square has increased. So for that, use double quote the first R square, and then we subtract it from the second R square. And then if you just divide it by how much incorporation was there, how many variables was needed to incorporate such an increase, right? So that is, in our case, was 2 variables. Okay? So this particular parameter is 2 here. If you now close the argument here and then divide it by again the leftover residuals that we have, that is 1 minus the remaining variability, which is this one, all right, the R square of the unrestricted model, 1 minus that one, and here we divide this by, if you close the argument and we divide this by the unrestricted degrees of freedom that we have here. This. So basically what we have here is that the first portion is the change or the differences adjusted variability, explained variability, and it is divided by the adjusted unexplained variability here. Right? If you just close this argument and hit enter, this is a very baseline system of bringing f-stat. Again, if you do not have f-statistics theories in your mind, you will not be able to connect these practical methods too much from the data or the insights that you're practicing. So I suggest that you attend the classes we did for the theories to understand. We did refer to two books. One is Damodar Gujarati, and the another book was N.G. Das. Both the books are very interesting. You can just go and read those books a little bit, and you will be able to understand that how you can deal with dummy variable data, right? Or you have categorical variables which is asked, to process and analyze in a regression model. All right. So this is for the f-stat here. See, the f-stat value is much higher, a much positive higher value. So it is likely to become a significant insight. Now for the restricted p-value, similar to the last one, just put equal, then t.dist t-dist.2t. Open the argument here, and then we again need the absolute value of this ABS, then the f-stat, then put a comma, and then select the unrestricted residuals of the first model there, the degrees of freedom. Then just log this using a $sign. Close the argument here, the argument here to properly close this, and then if you just hit enter, see, we have a p-value much lower than 0.05. That means the revision program itself has significant impact on the productivity that we have. Alright, so the program alone explains a lot of changes in our data. So this is how we go and understand about regression models. Now, in most of the cases, when you go for a direct analysis option, where you might also been asked to calculate this stuff manually. So if you do not have a good grip on the theories, you might get affected by the differences in the data that you have, or the different kinds of observation that you might find. So it's better, we suggest that you learn the lineage functions and so on. Alright, so I hope this video has helped you all, and the decision making process for the dummy variable regression is clear to you. So this is how we observe and see the data that we have given to our disposal. Alright, I hope you will attend the further classes as well and have a good time. I'll see you in the next class. Thank you so much.